Hi everyone and welcome to this new video. In this video we continue the Active Directory Exploitation series. Now here I have my domain controller up and running, the one that I showed how to set up in the first episode, and in this episode we will run a simple nmap command to enumerate the open ports on the domain controller. We will get this output with a bunch of ports and services, and we will analyze together each service. What is the purpose of each service? So here I have a list of Active Directory specific services and then of general services that are not shown in the output but that are still useful to talk about. And I want to talk about these services because when you run, the first time you run an nmap on a domain controller, you get a lot of output. So the objective here is to understand which part of this output is useful to us. What are the potential entry points for our server? As always, I hope you find the video enjoyable and interesting. If you do, leave some feedback, subscribe to the channel and share this video with like-minded people to help me grow here on YouTube. Thank you very much. Enjoy the video. So let's start off by analyzing this nmap command. So here I have the shell with the nmap command. So this is a very famous and common tool to enumerate an attack surface of a product because it scans for all the open TCP and UDP ports. So in this case, this command is just going to take care of the TCP ports, but with a flag, you can also specify UDP ports. In this case, we are mostly interested in TCP services. Then we find these three different attributes, these three different flags. So -pn, -sv, and -sc. So let's go through each one of them in order. SC is to execute common scripts in the nmap engine. Because nmap does not only tell you if a certain port is open, the tool is also able to interact with common services to perform a common action. For example, in the context of SMB, we might have anonymous access to the SMB share. Same thing for an FTP server. There are scripts that test for this common action that we can perform on well-known services. Another, for example, is to grab the HTTP title of a page. This can be useful information to include in the report, and so we want to execute the default scripts for each service analyzed. Then we find the -sv, which instead tries to fingerprint the specific version of the software. So this tries to grab the so-called version banners, the textual information that is returned by the server, by the service in question, and that contains information about the version, about the type of software. For example, there might be different SSH implementation, there might be different SQL implementation. Is it running MySQL or is it running Microsoft SQL? So depending on the implementation, you might have different version banners. And so with the -sv, it also tries to match, okay, what kind of implementation is this service running? And the -pn flag is because by default, Windows drops the ICMP packages, which typically nmap uses at the start of the scan to understand if the host is up and running and if you're able to connect to the host. Now in the context of Windows, however, you need this flag because Windows drops the ECM packets. It means that if it receives ECM packets, it's just gonna drop them. And so we need to say, okay, do not do discovery host at the start of the scan. Assume that it is up and running and go forward from that. And then we have the IP address of the domain controller, of course. Now, before starting the command, I want to mention this thing. Now, in these first videos, we will directly interact with the domain controller. This is because if we look at the network configuration, at the network layout, our attacker box, which is the Linux machine from which we are running the command, but this can be also a Windows machine, it can be a Mac OS, whatever it is the case, it is our attacker machine. So the attacker machine and the domain controller, they are connected because they belong essentially to the same network. So there is a router that is handled by Camo in this case, and they belong to the same network, so I have direct connectivity. Now in real world scenario, this is most often not the case. Why? Because exposing a domain controller to the internet is very dangerous and should never happen. I mean, there is no reason why you would expose a domain controller over the internet. For example, consider the OSCP setup for the exam. How does it work? You have your attacker machine, then you have an MS01, which is a workstation that exposes some servers, and then you have the domain controller, and then you have a different workstation. Now, they are connected within a network, right? And then your attacker box is connected within MS01. So you do not have direct connectivity to the domain controller. Now, this is much closer to what you would see in real life. Of course, in real life, you don't have just one point and then you're good, but typically maybe you have different layers that you have to go through essentially. So in this kind of setup, the idea is that before even getting to the domain controller, before even enumerating the attack surface on the domain controller, you actually need to attack a different target, like a workstation, a Windows server, whatever it is. First you attack that, then you establish a pivot point. So you do pivoting with, for example, SSH, with a bunch of different tools, and then you are able to essentially execute your commands from this new point, for example, MS01, and then you're able to ping the domain controller to interact with the domain controller, and so on and so forth. So for this first videos, however, we're gonna have direct connectivity to the domain controller. Now, I've already run the nmap command and I got this output. So how can we read it? Well, here it contains a bunch of information about the timestamp, the version of nmap, whatever. And then here we have the juice, we have the meat, we have the stuff that we are interested in. So we have the open port, the state of the port. So here we have the port, here we have the state, here we have the type of service, and here we have the version of the service. So we start with an open port 53, then we have 80, 88, 135, 139, 389. So we have a bunch of different services, and now we will go through each one of them to describe what is their purpose, what is their role. And here I've actually prepared these notes that you can find down below in the content material you can find in the GitHub repository of the XNAMP project. And here is an order list of all the different protocols. Every attack essentially is going to use one or more of these protocols. So this is why you need to understand everything that is going on at the domain controller. Now, of course, when it comes down to it, the attacks themselves, they are most often just commands that you execute. However, if I just show the commands, I wouldn't build understanding. I wouldn't help you to build understanding over why those commands work and what they do exactly. So now we will go through each one of these protocols. So let's start with port 53 DNS. Now there's not much here to say if you know already DNS from the web. It is the same service. It is the domain name system. It is responsible for translating human readable domain names into machine readable IP addresses. And here is a simple example. Remember when I set up the hostname DC01 on the domain controller, and then we set up the name xstamp.lab for the domain controller, right? So this is essentially the name, the symbolic name that is associated to the domain controller, dc01.xstamp.lab. However, when it comes to the TCP/IP stack, to the network stack that gives connectivity to machines, the underlying protocols do not work with these kind of symbols. They need IP addresses, which just define a sequence of bits. So they just memorize destination and source points in the network as a sequence of bits. So they know that in the network, the domain controller will be associated to this particular sequence of bits. Now, the DNS is extremely important in the context of Active Directory, because remember, in Active Directory, we do not have just one computer. Most of the time, we have many different computers connected with the domain controller and with each others. So we need a way to quickly understand where in the network a certain service is located. As humans, it's really hard to remember a specific IP address, and this becomes even harder when you don't have one machine, but maybe you have 20, you have 30, you have 100 different machines. If instead you have a well-structured domain name systems that enumerates all the different domains in your directory, it's much, much easier. You know, maybe you can have hr.something, you can have dev.something. It's just much better. So the DNS allows browsers and other applications to connect to websites and services on the internet using easy to remember names instead of numerical IP addresses. And in this command nslookup, I'm looking for the IP addresses associated to dc01.exam.lab, and here I get my IP address. Now, in the context of Active Directory, the DNS protocol plays a critical role in helping clients and servers locate resources within the domain. Without DNS, clients would have difficulty locating and interacting with AD resources, and things could break. Because remember, here we're not talking about just human clients or just normal workstations. We're also talking about like services, like things that happen on the background, things that run on the background that most often we don't even see directly. However, to do the synchronization, to do the duplication of data and things of the sort in all those systems, we need a reliable way to go from domain names to IP addresses, because at the level of the configuration, we use domain names to configure stuff. But then in practice, when these systems need to talk to each other, they need to translate those symbols into IP addresses, and therefore you will always find in one way or another a DNS in the context of Active Directory, which of course means in terms of exposed attack surface that all the attacks and enumeration you can do on a DNS, you can also do here in this context. And for example, in the web exploitation series, I talk about the DNS zone transfer attacks, right? So those kind of things can be applied here too, because we are interacting, after all, with a DNS server. So this is it for DNS, and we can go to the next port, which is a very classical port. So here I'm not going to say much, HTTP port 80 TCP. So this is the typical web. Now consider this, I do a simple curl, and this is the request that is generated by curl. I can see it because I put the -v into the command. So curl gets me the header for the request and the header for the response. So this is the response that is generated by the server running on the domain controller. And notice on the server header, I get Microsoft IIS 10.0, which is the Microsoft built-in web server. And of course, we can also go directly to the server using a browser, which after all is a web client. And here we see the welcome page for the IIS Windows web server. So that's pretty basic. Now, of course, remember that in port 80, this HTTP protocol is exposed without cryptography, because by consensus, port 80 has no cryptographic protection. This means it is vulnerable to many different attacks, including man-in-the-middle attacks. And it also means that the traffic is not protected with confidentiality and integrity. You can see port 80. And if you wonder how I install it, well, I'm going to show it real quick because it's simple. So you take essentially the lab that we had previously, the one that I showed. Then you go into Manage, Add Roles and Feature. You go into Next. You go into Next. You go into Next. And then here you select Web Server IIS. So you select Web Server. You select all the different services that you want to be installed, all the different features. So for example, in this case, I don't want to add any more essentially, but that's the idea. And then you install it. So when you want to install something, always use the server manager, which is your interface with the system installed on the server. And since IIS is built in by Microsoft, it's really easy to just install it with the add roles and feature. And here we can find it IIS. If we actually want to put encryption, we have to disable port 80 and we have to enable port 443, which exposes the HTTP protocol, but with the added protection. And we will go through that later. And with respect to the attack surface, exposing port 80 or port 443, the secure one, can be a great danger depending on the type of application that we expose. Because web applications are by design very complex most of the time. This means that all the functionalities of this web application increase by a lot the attack surface exposed by the server. Which also means, from a strategic point of view, that in a domain controller, you should not really expose web applications that could be vulnerable to web exploitation attacks. So that's the idea. Now, in the channel, you can already find a series on the basics of web exploitation. That series, of course, does not cover all different web exploits. It is mostly targeted at an audience that wants to obtain a DOSCP certification. In the future, I plan to make more thorough content of web exploitation, but for now that is good. And so now we can talk about Kerberos. So as I already said in the previous video, Kerberos is a network authentication protocol designed to provide secure authentication between users and services in a network. Now, specifically in the context of Active Directory, clients and services to deal with Kerberos interact with a component known as a key distribution center, so KDC, and this service listens on port 88 TCP. So let's go back to the output. Here we have port 53, simple DNS, port 80, HTTP with Microsoft IIS, and then we find the port 88 TCP Kerberos sec with the server time. So this is the KDC of Kerberos. Now this actually consists in two different components, the authentication service and the ticket granting service. Now the objective of the KDC is to authenticate the clients and return to the clients so-called tickets. So the KDC is responsible for issuing these tickets, which represent proof of authentication. So the idea is that instead of sending all the credentials all the time, they just send them once to the KDC to obtain special tickets, and then these tickets are used when clients want to use other services. So here, I will not go into depth here because I will make a specific video on Kerberos, but there are a bunch of different attacks on Kerberos. For example, we find the Kerberosting attack, Kerberosting, which of course targets Kerberos authentication. Now, to interact, to authenticate, and to do stuff with Kerberos, you can use any Kerberos clients, and in the videos where we will cover typical and the most common attacks you can do on Kerberos, such as Kerberosting, we will use specific clients that implement the Kerberos protocol. So that's the idea. So this is it for port 88. Then we find port 135, which stands for Microsoft Windows RPC. And in the nmap output, it's port 135. It's this one. So Microsoft Windows RPC, where RPC stands for Remote Procedure Call, is a protocol that allows application on a Windows machine to communicate with application on other machines. So basically, the idea is that with this protocol, you can execute stuff on a Windows machine, on a Windows server, from both a Linux, Windows, Mac OS system. So this part specifically facilitates the RCP endpoint mapper service. So the endpoint mapper service helps client identify the correct port on which an RPC service is running on a server. Because essentially the idea is that RPC, which is called Remote Procedure Call, does not only use port 137, there are actually other ports that are used. So to understand which are the open ports, which are the open service that are exposed on the machine, 135 is used. It's sort of like an entry point. You go into 135 and you ask, hey, what kind of service can I use here? So consider this command, for example, RPC client. So here I put the username and the IP of the domain controller. It's gonna ask me the password for the username. I put xdump13123 exclamation point with the H capital. And then after I am authenticated with the service, I can execute, for example, this enum dom user. So enumerate the users of the domain. And here I get administrator, guest, KRBTGT, Leo, and test. So that's the idea, we can execute different functions. And with respect to the attack surface that it represents, now for basic attacks, we will not interact with it too much. However, if you want to do more advanced research, then this is an extremely useful and interesting endpoint to understand, but it's still important to mention. Then we find the port 139 with the NetBIOS. Now, this protocol is mostly legacy, it is not used that much. Initially, it was developed to run only on local area networks, but then it was adapted to also run on TCP/IP stacks. The idea is that initially it was used for file and printer sharing, so for communication of files and printer resources, but to be honest now, the protocol that is actually used is the SMB protocol, which runs on port 445. Therefore, this one is mostly considered legacy. For example, you can interact with the machine using nbt scan, and you get the NetBIOS name, so you get the domain name here, the name of the computer, the host name of the computer. You get a bunch of simple information actually on the MAC address. There is some basic enumeration you can do with this, but it's mostly legacy, I would say. So this is the NetBIOS, and here in the introduction here, we find the NetBIOS here. So next in the list, we find LDAP, which sits at port 389 TCP, and here we can see 389 TCP LDAP. So as we said in the previous video, LDAP stands for Lightweight Directory Access Protocol, and it is a protocol that we can use to interact with the information stored in the Active Directory. For example, in Arch Linux, in any Linux distribution, we can query an LDAP server from a Linux machine with the LDAP search command. And notice, like for example, in this case, we put the LDAP protocol, the example.lab, here this domain, because I've set up rules that resolve this domain to the IP address of the domain controller. And this means that in my file /etc/host, I've set up a new rule, a new line that says, okay, example.lab, and then here I put the IP address of example.lab, so whatever that is. And then here, essentially, I put the kind of, so here is the query that I want to do, this B, and with this D, I'm authenticating myself. So who am I? Who do I want to authenticate as? And as you can see, LDAP has this syntax, where, for example, I want to say, okay, Leo that belongs to the group users to the domain exam.lab. This is the password of my account, and this is the query that I want to execute. Now, if I execute, for example, this command, this LDAP search, I'm going to get a bunch of different output. There's also this LDAP whoami that is used to understand if we are properly authenticated to an LDAP server. This operation is called binding, it's called like its basic authentication. And here it says example/leo, so like I am binded as this particular user. And of course here we could enumerate resources, we can get some kind of sensitive data depending on how the LDAP server is configured. So this is another extremely important attack surface. We can use it from a Linux machine, but also from a Windows machine. Because for example, if we go into the workstation and we log in as the user Leo, essentially, here for example, we can execute this PowerShell to search for all the users. And this is the way that LDAP is typically used. If we get code execution on a machine that is joined into an Active Directory domain, we might develop, and in the course we will, some simple LDAP commands, some simple LDAP query to get information out of the system. So that's very useful. For example, in this case, I put a filter that says, I want every user. This is going to be the root organizational unit, which is the entire domain. And then here, essentially, I create a directory searcher. I create a new object. Actually, here it's this entire line. So here I have to put this entire line. And then I put the filter. I put the search scope to sub3. And then I do find all. And here I get all the different users of the machine. Of course, there are much better ways to do this. Just to get you to know, this is LDAP, is exposed on port 389. So if you see a service on 389, most often than not, it is LDAP. Then, of course, we find HTTPS exposed on port 443. In the output, actually, here we do not see, because I've yet to configure an HTTPS server in the domain. Now, what it adds security? Well, it adds 3 main services, which is authentication. So this means understanding who is the server and potentially who is the client. So authentication in TLS can be done with mutual authentication, which means that the server can authenticate the client, and the client can authenticate the server. Now, sometimes this is a key part of Active Directory with the certificate authority and things of the sort. And then we find, of course, protection over the confidentiality and integrity of our data. So confidentiality with respect to who is authorized to see the data itself. It means that it's going to be encrypted. And integrity, instead, with respect to who can modify the data itself. And so with this, we obtain HTTPS, because remember that the protocol stack is, we still have HTTP, but now we don't have just TCP, but we have TLS over TCP, over IP, and things of the sort. So this is the secure version, HTTPS with the S. Normal HTTP is like, okay, I have HTTP, and then I have TCP, and then I have IP. So here what is missing is the TLS portion, which provides all the protection. And of course, in Active Directory, you can set up a TLS support. You can set up even a certificate authority, which is an entity responsible for managing a TLS X509 certificates, which are used for authentication. So there's also all that attack surface. Now, in basic Active Directory exploits, you don't deal with certificates, but there's also a key portion of Active Directory, which we'll see towards the end of the series because it's important. And so this is HTTPS. In port 445, we find a very important service and protocol, which is the SMB protocol, which stands for Server Message Block. So this is a network protocol that was developed for file sharing, for the sharing of resources, and also of printers. So it enables computers to share files, printers, and other resources over a network, and essentially this took over the NetBIOS protocol. So SMB supports multiple features: file sharing, printer sharing, RPC, which is the remote procedure call, inter-processor communication, IPC, authentication, and security. Now, there are different versions of the protocol, of course, because every protocol has its own complexity. There is version 1 and 2 and 3. But version 1 is deprecated because it has several security vulnerabilities. And if you remember, for example, in 2017, there was WannaCry, which essentially attacked a lot of different computers that were running a vulnerable version of SMB. So the more secure versions are 2 and 3, of course. So that's the idea. Also, version 3 even supports end-to-end encryption. Now, this can run over multiple ports, TCP/IP, NetBIOS, or also over UDP. Now, you can easily play around with this SMB file sharing feature in your own setup as follows. You create a folder and you put any file in this folder that you want to share. For example, here I have on the C drive C/share file with a simple test.txt file. This is an example of file that is shared using SMB. So after we created the folder that we want to share, we right click on the folder, we go into properties, we go into sharing, we go into share, and here we can change the way we want to set up the stuff. So here I can see the different users of the domain, and I can change their permission in read and write. For example, I can say, okay, Leo, I want in read and write, but test only in read. Then I click on share, and essentially the folder has been shared. Now I go into the workstation, and I go into this path //dc01/share files. So I go here in the file explorer, I pull this station, and notice that I have access to the file. So this file was shared using SMB. What is going on underneath all these user interfaces is the SMB protocol. Now I can modify it. I can modify the file. I'm gonna save it. And from this other end, here essentially, I have the changes that are, of course, synchronized with respect to the Windows services and the SMB protocol. So that's a very simple idea to get you started. Of course, you can also access the shared folder over a network from a Linux machine, and this is what we will do in one of the first videos where we attack the different protocols. A typical misconfiguration is if you have open shares, if you have open folders that are shared over SMB, for example, with the SMB map and SMB client commands. We will go into depth on the specific video. So I just want to mention in this video that SMB is a very important portion of the attack surface because this is most often used by people. They share a lot of stuff and not always things are well configured. Sometimes they are too open. Sometimes things are shared that should not be shared, and things of the sort. So a very important attack vector to consider in the surface. And here in the output we had this 445 open Microsoft Yes. So here there is this question mark because nmap is not sure, 100% sure that this is the service, because in this case we had nothing open, so it was hard to tell, but it is open actually. So that's the idea. Then we find the port 464 TCP, which hosts the service kpasswd5, And in the nmap output, we get 464 TCP open kpass2d5. There is a question mark. It means nmap is not 100% sure, but that is actually the service. Now, what does this service do? Well, if we analyze it, essentially, this port 464 is used once again by the Kerberos protocol. However, this is used specifically for password change, to implement the password change protocol in an Active Directory context. So it works alongside Kerberos authentication, and it provides the specific function of password change. That is, it allows users to change their passwords using Kerberos. So the kpass2d service ensures that the password change is done in a way that preserves the security of Kerberos and the user ability to authenticate within the Active Directory domain. And this is needed because, of course, Kerberos and Active Directory is a complex system. So just for a simple password change functionality, actually it's not that simple and it requires its own protocol. Continuing, we find port 539, which is used for Microsoft Windows RPC over HTTP. So it is similar to port 135, but it's just a different, so like this is RPC over HTTP. So HTTP is the communication channel used, but the messages are RPC, so remote procedure calls. So this is also used for distributed DCOM services that need RPC access. This is more advanced stuff. In basic Active Directory, you do not exploit this stuff, essentially. So in the first videos, we will not see much of these ports. Then we have the 636 LDAPs. So this is similar to HTTPS. This is LDAP over SSL TLS. So it is the secure version of LDAP. Because once again, remember HTTP is the not secure version, HTTPS it is the secure version, with LDAP is the same thing. Port 389 is without encryption, port 636 is with encryption. And if we go into the nmap output, we find 66, it actually says TCP wrapped. So it means that nmap is not able to recognize the service, but by default, by design, it is supposed to host the LDAPs, LDAP over SSL TLS. Then we find these other two ports, so 3268 and 3269. Now, these ports offer the so-called global catalog, abbreviated as GC. I've also mentioned this in the previous video. It is a partial read-only replica of all the objects from all the domains in the forest, and it is optimized for search and authentication purposes. So here the difference between these two ports is that one is GC over LDAP. So it means that it uses the LDAP way of searching information. So it uses the LDAP protocol for communication, while this other is GC over SSL TLS. So once again, GC with encryption. So as you can see, most of these ports have the unsecure version without encryption and the secure version with encryption, but the service essentially is the same. And finally, we see these other two services which are at port 5357 and 5985. This here is the same, Microsoft HTTP API HTTPD 2.0. So this is an HTTP API that is used to offer two services, which is the SSDP, Simple Service Discovery Protocol, and the UPnP, Universal Plug and Play. So these services are used for the discovery of devices and services on a local network, for example, smart TVs, and the plug and play allows devices like routers, printers, and other networker devices to automatically discover and configure each other without manual configuration. So that's the idea for this 5257, and then we find this other 5985. This other instead is for the implementation of the Windows Remote Management, which is abbreviated as WinRM. So this is Microsoft implementation of the Web Services for Management protocol, which allows remote management of Windows system using a standardized SOAP-based API. So essentially here we can see, for example, from the domain controller here, from this machine directly, we can check that the service is up and running with this simple, very simple command. Here we open a PowerShell. We get service winrm. So get service winrm. We find that this is up and running, and we can enumerate the configuration. And if we enumerate the configuration, it's gonna say port 5985. So that's for essentially the remote management of a Windows computer. So that's the basic idea. And so this is it with this basic enumeration of Active Directory specific services. I mean, here technically the HTTP is not specific to Active Directory, however, it is important to mention. So that's the idea. Now, before actually closing the video, I want to talk about other services that are very useful to know. And these are the FTP, the SSH, the Microsoft SQL, and the RDP. So we start really simple with the FTP at port 21. So this is the simple file transfer protocol. It is a very standard and old protocol used to transfer files between a client and a server. You can find it on port 21. There are secure versions and not secure versions. So that's the idea. Then we find the SSH. This is the secure shell protocol. It is a cryptographic network protocol used to securely log into remote system and executes command over an encrypted connection. So this by design is actually secure. This is the successor of Telnet essentially, because Telnet is not secure, SSH is secure. It is a protocol that allows to log in into another machine using a terminal connection in a secure way. So it is widely used for secure remote administration, for file transfers, and also for tunneling, because SSH can be also used for port forwarding and tunneling, which is the technique thanks to which we can use an intermediate machine to access a domain controller that is not exposed in the internet. So the idea is that here we have our attacker box, here there is SSH up and running, and we can use this SSH connection to create a pivot point to target the domain controller. So it is an extremely useful service to know and understand very well. Then on port 1433 TCP, we find MS SQL. So this stands for Microsoft SQL Server, and it is an SQL service implemented by Microsoft. So if it is configured to listen to this port, application can access the server to interact with the database. For example, this is the command, one of the commands that we will use with the in-packet library, so with Python, in-packet MS SQL client. We put the username and the password, we put the domain controller, we put the dash Windows Auth so that it uses the credentials within the Active Directory system, and then of course we can execute SQL queries, and actually depending on how the database is configured, if it is poorly configured with an open MySQL instance, we might even be able to execute code on a machine, which means that this represents a very interesting attack vector for our attack surface in the context of Active Directory. And finally, we talk about RDP, which stands for Remote Desktop Protocol. It is once again a protocol developed by Microsoft that allows users to connect and to control another computer over a network via a graphical interface. So in this case, we have a graphical interface for managing the instance that we want to analyze essentially. So while SSH is command line based like Telnet, RDP is GUI based. So literally we see the screen of the domain controller, for example. We will see this that is however streamed over a network thanks to the RDP protocol. Now this is it for this third video of introduction to Active Directory. I can see that there's a lot of information here and I went over a little bit fast, but the idea is just to get you used to all these other protocols, and specifically in the next videos we will focus mostly on the SMB protocol to get started into how to exploit the basic misconfiguration, how to enumerate the SMB surface exposed by a server, and that is very useful in the context of Active Directory. So once again, I hope this video was useful, I hope you got something out of it. If you did, subscribe to the channel, share this video with like-minded people, and to the next video where we will go more in depth into the various attacks over Active Directory.